We're just going to have a look now at trimming moments that we create on a vessel. When our vessel is at even keel in the water, our buoyancy and gravity values have to be the same in the same line vertically. Just like when a vessel isn't listed and you've got the buoyancy and the weight forces equal and opposite, and of course when a vessel lists, then G moves off the centre line. So when a vessel is at even keel, B and G, LCB and LCG are exactly the same value. What then happens is the vessel may load, discharge and move cargo. As a result of that, the position of the LCG, longitudinal centre of gravity, changes. And if the two aren't in line, then this must create a trimming moment. We know throughout transverse and longitudinal stability it's all about the moments, and a moment is a weight times a distance. So in this instance, our trimming moments that we've created must be the weight, which is the weight of the vessel, multiplied by now the distance between B and G. If we can calculate the LCG and get the LCB from our tables, the difference between the two must be the distance that we use for our trimming moment. And it would stand to reason when we look at this sketch here that if our LCG was less than the LCB, or if the other way around, if B is greater than G, we must be trimmed by the stern because our gravity or weight force is aft of our buoyancy force. So if we just look over the next page, and we can see that it says here that the difference between G and B is the trim lever, which we've just talked about, and the trimming moment is the product of the lever and the displacement. If we've got the trimming moment and we divide it by the MCTC, which is the moments to change the trim by 1 centimetre, we can calculate our trim. And very important that you must realise that the trim will always come out in centimetres. On your formula sheet you're told that trim is displacement times LCG difference LCB over MCTC. The formula is written this way. That isn't a minus sign, it just means the difference between the two, because if we're trimmed by the head, then one would be greater than the other, and the opposite would be true if we're trimmed by the stern, as we saw from the previous diagram, where if buoyancy, the value of LCB is greater than G, we're trimmed by the stern. So we're quickly looking at example 1. In the above diagram, our displacement is 12,000 tonnes in the final condition, so we've loaded cargo, discharged and ended up as a displacement of 12,000. LCG is 72, LCB 73.2, MCTC 178. Calculate the final trim. Well, B is greater than G, so we must be trimmed by the stern. So all we do when we look at this formula, trim, is weight, which is 12,000, multiplied by the difference between the two, 73.2 minus 72, divided by the MCTC of 178, and we find that we have got a trim of 80.9 centimetres by the stern. Okay, so we're trimmed by the stern. Now that doesn't mean that the total stern trim is 80.9. What it means is our total trim is 80.9 and we are trimmed by the stern, meaning that our draft aft will be greater than our draft forward. That's an important point. Our total trim is 80.9 and we are trimmed by the stern. So part of that 80.9 will be applied aft and part of the 80.9 will be applied forward.